Hello everyone, good morning. How are you? So today we do section 5.2. We are going to prove some theorem on linear martingale. Okay, first let me remind you or recall that a stochastic process x sub t for t between a and b is called a linear martingale. With respect to a filtration script f sub t for t between a and b. If this is the definition of a near martingale, if for any s less than or equal to t, of course it is understood s and t are between a and b, the conditional expectation of x sub t given f sub s equals to the conditional expectation of x sub s given f sub s. And this is almost surely. And the difference between a near martingale and a martingale is a martingale is adapted with respect to a filtration, so that if x sub t is adapted with respect to this filtration, then the right-hand side is nothing but x sub s, and therefore it is a martingale. Okay, so we are going to prove some theorem on near martingale. The first theorem. This is, as you can easily guess, a near martingale is a martingale of course it's understood that is with respect to a given filtration. So a near martingale is a martingale if and only if it is adapted with respect to the given filtration. Okay, so here it is the proof. Obvious. Okay, now the second theorem is also obvious, but it's kind of useful to know because later on in application we need this. So the second theorem is this: let psi be a random variable integrable. So with expectation of psi absolute value is finite. Then a stochastic process except t given by psi for all t, say t is between a and b. So this is a constant stochastic process. It does not depend on t, it depends only on the on omega in the probability space. Then this stochastic process being constantly equals to psi is a near martingale. And let's give a proof. Let S be less than or equal to t, then you see we need to check this condition. So the condition expectation of x sub t given script f sub s is condition expectation of psi given f sub s. Moreover, condition expectation of x sub s given f sub s is condition expectation of psi given f sub s. And you see the right-hand sides are equals. Hence, we have the equality. Hence, we have the equality in equation star. Let me put this as star. This is star. That x sub t is a near martingale. And that is the proof. It is obvious. Okay, so let's go to the next page. This is page 38. Okay, I'm adjusting the position. Okay, good. So theorem 2. Next one is theorem 3. This will be a very useful theorem. A stochastic process x sub t is a near martingale. If and only if the condition expectation of x sub t given script f sub t, the same t here. So this is a given stochastic process, and it is a near martingale if and only if this is also a stochastic process. If and only if this stochastic process is a martingale. So the situation here is like this. This is in Ito theory. And on the ground, we have the concept of martingale. And near martingale is in the sky. This is the counterpart of Ito theory. And up there we have the concept of near martingale. And up there we have like an airplane. I don't know how to draw an airplane. Or it's birds. Okay, anyway, a bird. This is xt. And then we take the projection, this the image there. The image of a bird. Say this is the bird. And this is yt, where this y sub t is the condition expectation of x sub t given script f sub t. This is the image. And what it says, if x sub t is a near martingale, if and only if the image y sub t is a martingale. This is what it says in this theorem. Okay, let's prove this. This direction. So suppose x sub t is a near martingale. We are going to show that y sub t is a martingale. So you see, for any s less than or equal to t, condition expectation of yt given f sub s. So yt is the condition expectation of x sub t given f sub t and then given f sub s. And here we use a property of conditional expectation. See here, we have s less than or equal to t. This is b. So we have this stochastic process. First we condition on f sub t and then condition on f sub s. This is the same as the conditional expectation of x sub t given f sub s directly. And now by the assumption, x sub t is a near martingale. Therefore, is it x, wait a second. This is the same as, because x sub t is a near martingale. So this is the same as conditional expectation of x sub s given f sub s. But by the definition of y sub t, so this is y sub s almost surely. And so now you see conditional expectation of yt given fs is ys. Hence, y sub t is a martingale. Conversely, you just reverse the process. This is, you do it, okay. Exercise. So we have this theorem, which is very useful. In the next video, I will give you one example to show how useful it is. So we stop here for this video.